There's nothing mystical or magical about experience. It's just something you get by doing roughly the same thing over and over again. It's more about brute force than actual skill. And the reward for your efforts, for building experience, for trying again and again, is just an increased probability of success. But here's the thing. That probability is never truly, fully 100%. I've been machining for a while, but none of that experience was enough to save me from my ever-present nemesis, stupidity. Welcome back to Inheritance Machining. I'm on this journey of turning my lathe into a gear hobbing machine. That is, a machine for making gears. My lathe really liked this idea, and so I stood his compound upright, giving him the y-axis he never had. I think this will help me with making gears at some point down the road, but I couldn't ignore the fact that I now have, well, another milling machine. Pretty useful considering I only have two. Anyway, this newly discovered mill doesn't have much tool holding capability, and that bothers me. You might be thinking this is an easy problem to solve. I have a chuck on this lathe that can easily grip any tool my mill might, but just no. I want to do this right and make a true R8 tooling adapter. That way anything I can hold in my mill can also be held in my lathe, with style. This should be a pretty easy problem to solve considering I already have an example to base this on, but I'm warning you now, easiness doesn't account for the amount of idiot juice I drank this morning. Pop this MT5 to 5C adapter in the spindle, fish this threaded drawbar in from the back, and I can screw in 5C collets to hold material. Basically everything I need for an R8. Yeah, I know. R8, 5C, MT5, what's with all the code names? I don't know, but they're all different. So to make this possible, I do need an adapter to go from MT5 to R8, and then a thread adapter because the 5C drawbar doesn't exactly dance the tango with R8 tooling. These may seem like simple parts, but a lot of this geometry is pretty specific. I would definitely hate to spend a bunch of time making something that didn't work for some simple and easily avoidable reason. Thanks to our sponsor Bamboo Lab, it's no problem to measure once and make twice, when you forget how to read your own drawings. The ease of tweaking a model and letting my X1 Carbon do all the work is really what appeals to me about the Bamboo Lab environment. I don't want to become a printing expert, but I still want the advantages of printing, and Bamboo Lab hits the sweet spot. Their software makes it dead simple for a Luddite like me to just upload my model and print. Clearly, there are a lot of other features here too to model around in if you're really particular, but paired with their reliable hardware, I'm never praying to the extruder gods that I don't come back to an Italian bird nest. Unless, of course, that's what you wanted. But I didn't. I wanted this. A prototype of our adapter so I can check clearances and function. Something I highly recommend doing at the beginning of a project. It's like 3D modeling, but in real life. Which is exactly why I found it so useful for printing other prototypes for this moonlighting mill. I mean, what good is an extra axis without a DRO? Nice. I'll get that buttoned up later because I can't mention Bamboo Lab without talking about the impact it's had on my organization. I'm talking about Gridfinity, baby. And most recently, I've finally taken my wrench drawer from this to this. This upgrade's been a long time coming, but it wouldn't have even reached the top 100 of my to-do list if it weren't for my X1 Carbon picking up the slack. In fact, having this printer has made me physically incapable of tolerating any inefficiencies in my workflow, including my office. And once I broke that seal, I couldn't stand inefficiencies in my wife's workflow either. So now her tool chest has been properly gridfinified as well. Almost brings a tear to my eye. So thank you to Bamboo Lab for supporting my DIY habit. And now they're taking that commitment to the next level with the Let's Make It Fund, a massive initiative that backs the most ambitious projects out there with up to $500,000 in support. So please consider clicking the link below to learn more and submit your project, or follow my other link to check out Bamboo Lab's lineup of printers and supplies. Either way you go does a huge amount to help our channel, and I couldn't be more grateful. Enough time playing around in the theoretical. We have mistakes to make. Let's bring this thing to life in its final form. Metal. I want it to be hardened, not because I see myself using it a lot and need that wear resistance, but because I can. And it just so happens that the only hardenable tool steel I have on hand is also the only piece of metal in the size I need. I don't know this bar's backstory, and that's honestly kind of a personal question I just don't feel comfortable asking. So we're going to play this safe and just pretend like he's got a lot bottled up inside. I mean, internal stress. As I start massaging this guy into shape, he might get a little weird on me. Might start shifting around. So best to take out the biggest chunks first while we have the material to play around with. You know, rip the band-aid off and all. This way, if he really gets bent out of shape, we can still recover. But so far, not so bad. I'll use the boring bar to get it a little closer, but again, not taking it all the way because I suspect I'll need a little wiggle room after I throw this guy into the real fire. I'll use the compound to throw a little 60-degree chamfer in here, and the tailstock can play as emotional support while I work on his outward presentation. First taking this somewhere near the final diameter, then canting the compound to a conspicuously common angle. I'll work on the minor diameter while adding a little chamfery goodness. Another adjustment to the second most common angle, and we can bring the front side into shape as well. Just in time for something actually important. The Morse taper angle in this region right here. This angle is pretty random but also very specific. We got to get it spot on the 1.507 degrees. The most reliable way to set an angle is to run an indicator along something that isn't angled, like the tailstock. Some basic math tells me that 1 inch on the compound should give an offset of 26 of these little tick marks. And that's close enough for this first pass. Now it's just a matter of etching that permanently into our soon-to-be adapter. The other angle of importance here is the one on the inside, the one for the R8, which of course isn't actually 8 degrees. I took the time to dial this angle in as well before realizing, yep, with that tailstock on, this guy's all over the place. So let's sever him from his dead weight and take a more refined approach. Everything's fixable with a 4-jaw chuck. I'll center this on the inner bore, then use the special angle we dialed in before to cut the taper. Flipping this fellow over, we can trim his backside, break some of his harsher edges, and we're ready for the real transformation. Making old Softy here much, much harder. I'm talking about heat treatment. It's going to take a while to get this guy up to temperature though, so might as well finish up our side project from before. My printed brackets are nice and all, but they were always just prototypes. I didn't want to stray too far off topic making their metal replacements, so I ordered them from Send Cut Send. They're the perfect service for something like this because they're easy to use, have no minimum order quantities, offer a whole bunch of services and materials, and somehow on top of it all, are fast. It sounds too good to be true, but somehow isn't. Get 15% off your order of laser cut parts when you go to sendcutsend.com/inheritance. That's the compound axis DRO mounted, but if you're nosy like me, you're probably wondering what these other brackets are for. Well, there's one last thing on this machine that has never been properly given a readout. The tailstock. Currently, the resolution on this hand wheel is appalling. How can I be expected to repeatedly drill to depth when my depth tolerance is wider than my attention span? But with a proper DRO, caution on the word proper, I can hold depth better than any other person in this shop. Gotta get it mounted though, and this is where I realized I didn't give proper reverence to a problem I thought of when designing these brackets. Because while drilling and tapping cast iron is about as easy as cutting cheese, the quill is not so cheesy. And my high-speed steel drills and taps just aren't going to cut it. I was really at a loss for what to do, and then it hit me. JB Weld. My grandfather used to tell me about a guy he knew who JB welded a quad's crankshaft back together, and if that's even half true, I think it can hold up to the extreme forces of this DRO. Let's get back to the real project here and see what's in store for our hot little buddy. I was prepared to see him get all bent out of shape, and well, dropping him right in the quench oil might make that a reality. Yeah, I didn't mean to do that. So fingers crossed the uneven cooling doesn't screw us. Well, it still looks round. Let's pop it back in a slightly cooler oven for a fragility removing temper. Now while that cooks up, again, we have something equally important to cook up. A thread adapter. This drawbar isn't going to thread into our R8 tooling all on its own, so let's help it. You're smart, so you probably could guess that there are going to be some threads involved. And not only are you smart, but you're also right. After some proper dimensioning and relieving, this end gets a nice 20 TPI helical engraving. Being able to make literally any thread is one of my favorite things about lathes. When a standard 5C collet calls for a not so standard 1.238 by 20 thread, we're never up a creek without a ladder. Adapters usually have two ends, so I'll get the rest of this material out of the way and we can ever so delicately grip the freshly cut threads with the soft aluminum jaws of the chuck before whipping up some much skinnier threads on this side. A fit's a fit, so let's fit this with some flats. Some weirdo decided that this face should be angled, but also left no dimension whatsoever. So I'll take the liberties that were granted to me and say, that looks about right. This might prove to be a little hard on the insert, but you never know until you fly. Now that's looking pretty fire, as the kiddos say on TikTok, but something tells me we can make it even hotter. I'm using a flame here because the oven is preoccupied and this is small enough that it will only take a minute. A small detail I did gloss over though, but you might have caught, are these letters. Believe it or not, they actually mean something. No idea what the 2 means, but the A, that's for air hardening. Meaning I can just let this sit here safe and sound rather than accidentally dropping it to the bottom of an oil bath. Once that's at room temperature, we can do a little swapperoo with the tempering cycle and get back to the main feature. The thing about this is it's hard, which is good, but also probably a little warped. Exactly the reason we left a little meat in all directions. Now we need to come back in and machine that meat away. But as you might suspect, not the same way as before. Don't worry, I wouldn't make you watch me perform all the same operations over and over again. That's for later. We'll do this the reverse of before though and start with the Morse taper, meaning we gotta set that angle. A different way this time though to keep it interesting. I'm using something that's already an MT5 as a reference. Center drilling a scrap for the tip, I can hold the other end with the live center and use this indicator holder that ensures the tip is on centerline height with the lathe while I nudge the compound into place. Spot on. Our part is next in the chuck, and after struggling to get it somewhat close to center, I'll do what I should have done first and work off some of that funky scale so I can really dial it in. I said the machining would be different, and here's what's different. We're going to grind this bad boy. This is necessary for 3 reasons. First, the adapter's now very hard and grinding is our best chance of success. Second, grinding will leave a much smoother surface finish. And third, likely the most important reason, because I can. This isn't exactly the best thing for a lathe, what with all the grinding dust and all. But the bath towels I stole from the house will give me the illusion that I'm actually protecting something. After a wheel dressing to make sure the grinding face is parallel to my compound angle, we can add sparks to the list of things that aren't good for this lathe. See, I told you that finish would be freaking killer. But the real question, does it fit? Yes and no. Looks like I went just a hair too small on the diameter. And now the whole thing goes in just enough to bump this chamfer that I left a little too close in my design to begin with. So we need to do something about that, without breaking down this lathe setup. Luckily I have a whole other lathe in here that I try not to think about. But I don't have another grinder, so we're just going to have to try our hand at hard turning. Which is just a fancy way of saying turning something hard. Though I do wonder, with how easy that just went, I'm not sure how hard this thing actually turned out, but not curious enough to pull out the hardness files. No need to put numbers to my incompetence. Anyway, let's do the old marker test. Looks like it's only touching on each end of the taper. This tells me there's some sort of concavity going on here in the middle. Considering this is the best that I've gotten after 3 different tries that I didn't show, I'm going to say, let's roll with it. The rest of these outer faces aren't functionally important, but you can't just leave it looking like that. I mean, you can, but we can't be friends. That scale really takes a beating on the leading edge of the wheel though, so a redressing before the final pass is necessary. We'll dial in that overly common but so aesthetically pleasing angle once again, for the chamfer of course, and then back straight with a hollow dressing on the side of the wheel so we can work just the tip. Now we have the insides of this guy to take care of, and like I keep telling you, you're smart. So you know we're not going to use this wheel. We're going to use this one instead. Except in another unsurprising turn of events, my lack of thorough consideration has confounded me once again. This internal grinding spindle, my only internal grinding spindle, isn't long enough for the job. Luckily, because of some other haphazardly made decisions, I know I'm not completely on a roof without a paddle. So we'll just bore this sucker the only way we know how. On the bright side, from what I can barely see of the surface finish in there, it's pretty freaking acceptable. And before long, I've got the diameter absolutely dialed. So let's take care of that last and final surface, the R8 taper. Same angle setting as before, this time with our little friend. After clearing the whole face of the carbon deposit I really wish was still in the steel and discovering that the angle is still a little bit off, I'll use the taper we just ground as an adjustment reference. Then bring the wheel back in for another stab at it. This is the only downside of the marker test. It doesn't tell you how far off you are, so you're really just going by gut. But the one thing it does exceptionally well is tell you when you're dead effing nuts. Alright, I've still got the backside here, but everything else is done, including the thread adapter baking cycle. I can't resist seeing if this is all going to work. Did I account for everything? Did I hit all my dimensions correctly? Will this actually hold a piece of R8 tooling? No! Alright, I'm going to spare you the hour it took me to find the problem and just show you this. You see that number right there? The 2.720 inches? That's the distance from the front of the 5C collet adapter to the end of the drawbar inside. Now here's the model. See the problem yet? I used that dimension for the wrong thing. I, stupidly, referenced the front of the spindle nose, which is quite a bit off from the front of the adapter, meaning our highly refined piece of tooling here holds sub-thou precision and is still a full inch off from the right size. I've literally been a thousandth wise and inch foolish. Now you're probably wondering why I didn't catch this during the prototype phase, and I apologize if my inept attempts at sarcasm slipped your notice, but I didn't actually prototype a thing until right now. This is the one that should work. A bit longer out here and a bit shorter on this taper, but otherwise identical. So rather than walk you through the exact same operations, again, I thought I'd show you a little peek behind the camera this time, at what actually appeals to me so much about this hobby. Finding that groove. A lot of people could find the exacting nature of machining frustrating, spending hours upon hours working on something that in the end either works or it doesn't. And when it doesn't work, it's easy to look at all that time as a waste. But I choose to see it differently. For me, this is a hobby, a true hobby. I care about the end result, of course, but not nearly as much as I care about the journey to get there. Quick is fine sometimes, longer is great, and even repetitive is better than not spending time doing something I love. Standing in front of these machines, working with my hands, and sculpting something I'm interested in from a hunk of metal. While you may not have a need for an R8 tooling adapter for your lathe that can hold drill chucks, end mills, and fly cutters, there's probably something floating around in that beautiful mind of yours that you could make yourself. So go try it. Fail if you have to. Be a little grumpy while you do it again, but do it. Because the thing about experience is, it's all yours. Thanks for watching, and see you next time.
Sorry.
Always be recording.
I know, always be recording.
Okay.